What you'll be doing in the lab this week, the lab sheet will be going out tomorrow, is I've got like a turbocharged user interface, if you can see that okay. And we're now adding a new bit which I've coloured grey down here. And if I hit account number 1 and hit find, it goes and finds DIT, our old friend from the random generator system. I don't particularly want to talk about him because he's already sorted. What I want to do is clear this guy and hit create new account. What should happen if I hit create new account? Is that a valid name? No. So I should get a message. I'm not getting one. That's not good. Okay. How about an age of 10? Is that okay? No. How about an income of -99? Is that okay? No. So what does the create account button do? It would seem nothing. Let's fix that. So I go in here to mainwindow.xaml and the program's still running, so I'll probably better stop it. And go down here and look for click on the create account button, there it is. And this is my code for it here, create new account. Does it have an event handler? Yes, it does. Let's go have a look at it. Right, it does nothing. Okay, that's good because there's lots of people I think would find it interesting to know what happens next. What happens next? Well, I'd like to make an account, but I want to make sure it's a good account. So we have a look in the account class, and in here it needs a bit of work on the layout, and it's a bit of a mess. There's other things lying around which I don't really care about at the moment. What's just happened? Edit, advanced, format document, bang, and now all the indenting's sorted out. Where's my set name? Okay, I need a way of asking whether the age and the income is valid before I can make my account, correct? And they also have to check to see whether the name is valid too. Is that also correct? Everybody okay? Right, so who's in charge of deciding if an account has a valid name, to pick name as an example? Who's in charge of saying like this name or don't like this name? The programmer, yeah. But which particular code element has that job?
The account.
The account has to be the account. So what I'll be doing, and I'll just make the text bigger so you can see it properly. I'm going to go in here and I'm going to change my code around a bit. I'm going to go and make a public static bool method called is okay, and I'll give it a string which is the name to test. And in here I can write something like this. I can go if name to test equals that. We don't like it, do we? Return false. I don't like that name, it's broken. Else return true. So if I like the name, I return true. If it's an empty string, I return false. Are you okay with that? Now, it's very important this happens in the account class and nowhere else, because the account class is the place which implements the business rules for how the account should behave. So when you press the button to say, I'd like to make an account please, it's the account that has the final say on whether the name or the account details are valid. So if I drift back to my behind window code in here, I would do something like this. I'll go and get the new name from the name text box like that. So now new name's got in whatever name we typed, correct? And so now I use that. And this is the bit that you really got to, is name okay, new name. So, dear. New name. And I'll put a not in front of there to invert that condition. And then in here, if I don't like the name, I'll go message box dot show invalid, don't like you, invalid name. Then I'll return, because I don't want to make an account if the name's invalid. So when we hit the create account button, we fetch the name out of the text box. If we like it, we keep on going. If we don't like it, we put a message up. So let's run the program and just see where we end up. So I'm going to leave that empty and hit create new account. I'll put a breakpoint here so we can see it always passed. So go back to the code again, Robert. Hit create new account. Go and fetch new name. Oh look, it's an empty string. That's not going to end well. Go into the account. I missed a step out there. I'll start that again. I apologise. I think I stepped over a thing by mistake. Run it again. Create new account. Yep, that's okay. Go in to ask the account, is this name okay? No, I don't like it. Okay, return false. Back comes false. Up goes the message box. So the workflow is invalid name. So do it again. Take the breakpoint out so you see it happen at full speed. Create new account. Bang, don't like it. So the way that you should make this work for all the elements in your account is to have something in the user interface that asks a question of the account to say, is this name okay? If the name is not okay, there's no point in us going any further. So we bounce straight out with a message, and then we give up on the behavior in this particular case because there's no point in going further. So the way it works, and you can repeat this process, I didn't help. Let's go back to where I came out of there. Oh, what's that OneDrive saying? I don't know. Oh dear. Okay, so if I go back to the account class, you can see that I could write something like public static bool age is okay, and int age, and in here I would go, well, what would I go? And I'd return if the age is less than 17, was it? Return false, else return true. And I've got the same pattern. So once I've actually got the name sorted out, I'll move on and consider the age. And so from here, I have to do some fancy footwork to actually get the age out of the age string and then do stuff with it. Does that kind of make sense? I think in the lab, I had a single method called allowed, which took the age and the income and returned true if they were both good. That's fine. It's just really a question of structure. The thing I want you to understand is that you ask the account, hey, is this age all right? Is this name all right? And then you reflect the behavior of the account in your user interface. This is really important because it means if the boss comes back and says, for some reason we're not going to allow people into our bank whose names begin with R for whatever reason, and so you have to enforce that business rule. So what you can do is just drift straight into your account class. How would I do that? How would I stop people whose name begins with R from making accounts in my bank?
Would you treat the string like an array?
Yeah, you can do that. I mean, that's from a technical point of view, it's actually easy. I would do something like this. If name to test 0, the first character equals R, then that's a bit stupid. Well, I should probably do it this way round. Because if I do it the other way round, I might end up trying to find a first character in an empty string. So if it's got an R at the start, I'll return false. Otherwise, I'll keep going. So I'll actually take this guy out as well. And I'll go down here and I'll go. It's a bit sad, nothing wrong with it. Return. So now, it does two tests. It says if it's an empty string, I don't like it. If it starts with R, I don't like it. Otherwise, I do like it. So once I've done that, everything else works. Everything else is fine. My user interface doesn't have to change. That's just a piece of business logic that I've now included to make a class that behaves better or more like how we want. Does that kind of thing make sense? So you have here's a question for you just to see how, why is this thing static? Why have I made the test method static? Why is name is okay static? Yeah?
You don't want to create a count, so you call what actually happened, the instance of the account.
That's pretty much close to an absolutely perfect answer. It's so you can call it without having an account lying around. I need to have someone to ask. If I haven't got an account, which I won't have, then I have to ask something, and because it's static, it means it's always there. Okay, so I can call this method before I've made my account. And so my user interface, I mean, to fully close it off, in my set name, what I do is I don't make this Boolean, I make this void, and then what I do is if I then do this, if name is okay, new name, if I don't like the name you've just given me, I'm going to get really, really cross. I'm going to throw an exception. That name. Bang. Otherwise, I set the name and carry on as if all was well. Now what's it doing? I'm not sure. I'm in two minds about all this clever layout stuff. So now my program, any attempts to set the name will quite simply explode if the name isn't correct. And the other thing which is very important to me is that all my name business logic goes on inside this one method. I use that everywhere that I need to check a name. That's where I do it. So the pattern I'm selling you is static methods in the class that implement the business rules in terms of valid things inside our object, and then every other method in the class that wants to know, hey, is this name a good one? Just goes off and uses that one thing. This guy is the oracle when it comes to knowing about good names and bad names. He's the one place in the world you can authenticate your names against. And so it's really important to me that it's in one place so I can fix it, and everything else picks up that behavior. So same for age and the same for income. That's how I would really do it. If you get to that point, then you're pretty close to what I will call production quality code. That's how it should be in real life. There's no way I can make a bad one. There is a way I can find out before I make it if it'll work or not. And I can put all that in my behaviors and make it fly. Does that kind of make sense? If you're still having bother getting your head round it, give me a bell, come and see me, whatever, and I'll go through it with you. The sample project, which I'm going to give out tomorrow, which is actually the basis of this week's coursework, has got these behaviors baked in. So you will be able to look at that code and figure out for how that code works, how it actually pans out. I'm trying something very different this year. I've revamped the first 3 courseworks, including this one, to give you a much better handle on making business objects and making line of business apps, because I'm hoping that when we go on to do the real coursework, you can take all the stuff that we've covered here and just slide it across into the way you're going to make your projects. That's kind of the aim I have for this. And with that in mind, let's get on with the show proper. But before that, of course, any questions? Can't see you now, of course. Any questions on that? Did that kind of make, was that helpful? Just keep in mind why you're doing it. I want to ask an account, is this name all right, before I have an account? So it has to be static, because otherwise there'd be no way getting the method to tell me that. So static means it's always there, and the standard reason for having static is I can ask questions of a class without having an instance present. And the whole name of the game is finding business rules and then putting them into our objects so they behave themselves and are sensible. So, yeah, let's talk about containers. Cricket scores, bank accounts. We used arrays. We're quite enamoured with lists, and we're learning to love dictionaries with a passion, because dictionaries are completely and utterly awesome. They're really nice, and lots of languages have them, including Python and whatnot as well. Lots of things in programs are containers, and lots of the times in code you're actually linking things together, putting them into some kind of collection mechanism. And you see this everywhere. There's a standard pattern. You either have a link with lots of these things or one of these things. And if it's lots, then you're into container country, and a dictionary is a good one to use, and we'll cover how and why in a second or two. So, we're pretty close to having a fully working bank application, which I think is kind of cool, because you're going to have something which is close to properly usable. We've got the UI looking quite spry, so now we have to do the back end to store the stuff. So in comes another class, the bank class, and the bank holds all the accounts. It's another business class, so it's not going to have anything in it which talks to the user, because business objects don't know where the user is, if there is one. They just have things you can ask them and things they can get you and store for you. And we will test it, because we test everything, because that's kind of a good way to go as well. So up until now, because we've been testing, we make an account whenever we need one. We just create one. It's usually called Rob for reasons of ego. In real life, that's not how it would be. It might be possible for me to make test accounts to play with, absolutely fine. What I can't do is actually just make accounts on their own. The only thing that can make accounts, really, is the bank. You can think of the bank as an account factory, okay? Because the account is in charge of the account number. Because the bank is in charge of the account numbers and what's a good one and what's a bad one. And it's the job of the bank to actually do that. So if you look at what a bank needs to do, well, it needs to make sure that these bank accounts are absolutely unique. I've already mentioned the fact there is a second Rob Miles at the University of Hull. Do you know this? He works in modern languages. I've actually never really met him, although I've received a few of his emails, and I'm assuming he's got some of mine as well. So you can't use people's names for bank accounts. You have to have a unique number for everybody, and so that's what we've done, and the bank must deal with this. In my simple-minded bank, I've actually got a counter that counts up from 1. So the first account is account number 1, second one's number 2, 3, 4, 5, 6. The bank is the place that actually produces those. And every account I work on, I'll get the bank to make it for me, and the bank will pick an account number which actually makes sense. And the bank knows which account numbers have been used and make sure we don't reuse any more. As far as we're concerned, though, I want to just spend a few seconds thinking about the bank as an object. Okay, so when we did the account, we thought, what are the things an account needs to do for us? And we came up with things like, what do accounts do for us? It's gone quiet. It's not a trick question. This is what things have we made our accounts able to do for us? Well, we can pay in money, we can withdraw money, we can change our name. On the full-blown one, you could change your address and other bits of it. So the account has a bunch of things it can do. If you look at the bank, these are the things I want my bank to be able to do. All the banks have a name, which is fine. So we'll give it a name like Friendly Bank Incorporated or Test Bank or whatever. And it'll have a bunch of methods. And I can think of 4. Find out what the bank is called. That's easy. Create and store a new account. Find an account by account number and delete the accounts we don't want. Does that seem reasonable? I'm just sliding across the stuff I know an account has to do and picking up what a bank has to do. If I was doing any other application where I have my container, I would think in terms of all the things that container has to do. So in my fast food application, I'd have stuff to do with the menu. Find a particular dish, add a new dish which the chef was actually creating, remove a dish that nobody's buying. These things tend to map across to pretty much every single collection-based app you're doing. So here we go. Those are what we want. And the bank name property is really, really easy to do because I can just implement a behavior that gives me a bank name on a get, and I can ask a friendly bank, hey, give me your bank name, and that's easy enough. This bullet point here is important. Once the bank has been created, we can't change the name of it. So it's just a simple read-only property. We've done those before with only the get, which is fine. These are the guys I'm really interested in. Add account, delete account, find account, and get bank name. Oh, I'm doing it both ways. Okay, I'll live with that. So, add account, give it the account name, give it the account address, and give it the initial balance. Anything missing from that? The name, the address, and the balance. What is it that, well, should it be there? Shouldn't it be there? Anything missing? The account number. Why is that not there? I'm so pleased someone said that. Why is the account number not given to the bank when I'm making an account? Say again? It is, but where does it come from? The bank is the only object in our system that knows how to make account numbers. And the bank is going to be fairly careful to only work on objects that have been sort of stored by that bank and brought back. Because we don't want anybody creating squiffy, dodgy, strange accounts and dropping those into the bank in some kind of odd way. So we don't tell the bank the account number. It gives us back an account with a number in it, which we can use. Getting your head around that is really, really important. Just think about what happens if you go and open a real account. You could never go up to the bank and say, I'd like to have a new account, please, and I want my account to be number 1. Not going to happen. They'll say, we'll give you the next account number that we're allocating, Mr. Miles, and you will learn to like that. Fine, okay? They control the universe, the ontology, the namespace, the whatever, of all the bank numbers. And it's their job to actually pick another one and give it to me. So I don't feed the account number in. I get back an account with the number set in it, which is fine, which is part of the bank, and it's all good. Delete account, I give you the account number, you remove the account. Find the account, I give you an account number, you go off and find the account for me. And get bank name, yeah, that's a way of getting us a bank without too much difficulty. That's all fine. So, constructing it. Well, we can give the bank a name. We might want to give it the maximum number of accounts. We could use an array of account references, but I want you folks to appreciate the true magic of the dictionary. So I'm going to tell you all that a dictionary is the way forward. Is everyone okay with dictionaries? And you are, of course, all aware that the word gullible is not in the dictionary, aren't you? And you've all gone and looked. Right, fine, worth a try. It is, you know, it is, I found it. It's not on Wikipedia either. Strange that. So, we're going to use dictionaries. I like dictionaries a lot. So, the thing that we know, though, is that we don't actually store an account in a bank, we just store reference to it. Because an account is an object, and objects are managed by reference. And if I say reference, you all say tag. Thank you. So the tag actually is attached to the object in memory somewhere, and all that the collection does, all that the dictionary does, is hold a bunch of these tags. And if I actually hand over an account to work on, what I hand over is actually the tag, not the account itself. And the program then follows that tag to get to the account to work on. So here's my bank constructor. Make a bank with a tag called Friendly Bank and give it the name Friendly Bank. Well, hey, the great thing about these guys, just to go back, just to underline where I'm going, when I've made these and made them work, people using my bank don't have to know how they work at all. People using my bank just call those four methods, and get the behaviours they want. They have no idea how it works inside. The underpinnings of the bank actually are totally hidden from how they work. This is a fundamental principle. I just grab the object and play with it. I don't know how it actually works internally. Here's my bank class, which I quite like. There's the name of the bank. There's my dictionary, which is string account. What does that mean? Whoa, string account, what's that? Yep, hand at the back.
It means that it uses string keys and each element points to an account object.
Yep, my dictionary lets me look up accounts on the basis of a string that I give it. This is perfect. I get the account number as a string from the little box the person types in. In fact, if you actually watch, you can see this work. You can see me find it. Find it. That's quite good, actually. That's almost amusing, but not quite. Run this up. No! Yeah, I'll just say yes. What the heck? Kabang. So, if I go in here and type 1, which is my account number, I can hit find, and up comes dip. And if I go 2 and hit find, up comes some other bloke. And if I go and hit find, it goes, I don't know who that is, account not found. So this is kind of working how I want. So the user can actually type in something, hit find, and up comes the person, and that's working on the basis of a dictionary. Dictionary gets this string, and it looks inside its little list of whatever it is it does, and it returns the account that matches that. So when I make my dictionary, I say, I'd like you to have a key, which is a string, and I'm indexing accounts, please. And the wonderful collection system in C# makes that for me. So that's my fundamental store. Isn't that nice? Now, in terms of the bank, this is the only way I can get hold of accounts. Nothing else will. These methods are the only way I can get hold of the thing, and that's all fine. Yep, I like dictionary because you can look things up on a key field, and the keys are all unique for everybody, and it makes it really easy. Our find account method is about 4 lines of code, tops. It's tiny. The code's a lot simpler, and dictionaries are really efficient, and it's all jolly good. So I make myself a bank, I give it a name, and this is my add account method. And in the lecture, the account is slightly fancier in that it has a name property, but the lab demo I'm going to give an address property, which in this case is Rob lives in Hull. But in the example code I'm going to give you, there is no address. One of the things you might have to do is put the address field in and make it work with addresses as well. But in the lab demo, no addresses. In the lecture, we have addresses as well, which is kind of cute. And so there you go. Rob lives in Hull and he has £100. Fantastic. We don't set the account number. We've covered this one already because we never set the account number. The bank does that. We read back the account number, but we never actually set it. It's manufactured for us by the method that makes a new bank account. Talking of which, here it is. This is the code that makes a new bank account. I love it when the code fits on one slide, and this one does. It creates a new account and it adds it to the list of the accounts held in the bank. The thing that's interesting that you want to think about here is the account number, which is set from this thing. This has been made static. What does static mean? It's always there. We only want the one of these because every time we make a new account, it has to get one bigger, which it does. There we go. And every time we create the account, we use a new account number, get a string from it, and slap it in the account number string. Then we make a new account, we give it the name, the account number string, and it goes off and sets it up. And then having done that, we increment the account number and go up by one. So this is the kind of approach I'm talking about. Does it kind of make sense? So the bank takes this thing, stores it, and pushes me the account back. I've taken the address bit out of here because it wouldn't fit on the slide otherwise. But the idea is that we can then get the bank to issue accounts for us. The technical name for this thing is kind of what's called a factory method, in that it makes accounts for us. It's a little factory that produces account classes which we can then use in our application, which is kind of sweet. So yeah, it's static because we need one for the entire bank class, and it just lives there once and gets one bigger each time. Bottom bullet point's important. Tomorrow I'll be covering how we save accounts and banks and bring them back, which is very interesting. We must make sure we save the new account number as well, so that when we bring the account back from the save file and start making new ones, the account number carries on and we don't have any duplications. So that's all extremely important to us. In terms of storage, here we go. There's my dictionary full of references, which is ordered, but we don't care about that too much. And each of the elements refers to a particular account object. And they've all got their own account numbers, they've all got their account names and balance values as well. So to find an account, well, before I go any further, is everybody okay with this? Did that kind of make sense? Questions, observations? Okay. I want you to think really about division of responsibility. Whose job is it to make new accounts? The bank does that. Whose job is it to decide if an account is valid or not? The account does that. So we think in terms of which particular object in our business does its job. And so now we're going to find an account. And the account, we find it based on the account name, so the account number. So here you go. If I want to find account A, friendly bank.find account 1. If it brings back a null, I write a message out saying account not found. Now if you want to see that code in living colour, then if I just drift into here and I go into bank.cs and I drift up to the top, there's add account, who'd have thought, and there's find account. And where's my code that actually uses it? Well, that's in here. If someone hits the find button, then where are we? Find account. Open account for edit this string, go to that. So here what happens is that I ask the bank, hey, will you find me the account with that number, please? If I get back a null, I say I couldn't find him, otherwise I open him for editing. So this guy returns null if it worked and the account if it didn't. Sorry, if it did, vice versa. And so away we go with this. This is very easy to use. This is nice. There's my method. This is, yep, 3 lines of code. And that'll find any account in thousands of accounts. Isn't it wonderful? I like this a lot. If you look at how it works, dictionaries, for those of you who may have forgotten how they work, dictionary, you give it a key and it goes off and finds the entry in the dictionary that has that matching key. Snag is, if the object isn't there, the dictionary throws an exception, which is a bit naughty of it. But I'm being in a kind of generous mood in that I'm saying I'll check to see if the dictionary contains the key we're looking for, and if it doesn't, if bank account, if notice that not, if it doesn't contain the key, I return null. That means I couldn't find this chap. Otherwise, I look him up and find him. And the cunning thing about dictionaries, which is nice to see, is that I put the key in square brackets like that. So it looks a bit like an array, but it isn't. It's just that's where the key goes. Does that make sense? Everyone okay with that? So this 3 lines of code means that I can now find my account and push it back if I find it, or a null if I don't. That's the null going back if I don't find it in the dictionary, and this is the account going back if I have found it. And it's just, I mean, in the previous versions of this code, I've actually been using for loops to search through it, or all kinds of unpleasantness. Dictionaries just work really, really nice, and so that's done that. So points to bear in mind which are kind of important. I'm not getting a copy of the account, I'm getting the real deal. So if I pay 50 quid in this, it gets the money straight away. There's no cancel button, there's no undo. I'm working on the real McCoy at this point. If that's a problem for you, and think in terms of buffering up your transaction or whatever until the user presses commit, that's your job. We're working on live data at this point. If you use Word, you see, if I'm using Word, I open a Word document, and if I use Word and don't press the save button, what happens to the original? Nothing. If I never save it, if I just quit Word, the original's still there in all its glory. If you've got Word running and you've got hidden files showing on your PC, you'll see that when you hit the Word edit button, a hidden file appears which has got a copy of your document in it, which it works on. And when you press save, it takes that copy and pushes it on top of the old one. That's how it works. So Word has been designed to provide you with this behaviour where until you press save, the original one isn't touched. That's not what you get here. What you get here is, as soon as I start working on this thing, I'm changing it, because it's the same thing. If you look at the thing from a diagrammatic point of view, if I go off and find the account for number 5, Mr. Miles, I get this. I get a tag called edit account, which points at the same element that the list points at as well. So I'm actually working on the same thing as is referred to by the dictionary. So it's the same thing either way. So if I pay money in, it happens straight away. That might be fine. That's a design thing to think about in terms of how you want undo to work and where. I mean, in the case of banks, an undo behaviour will be kind of dangerous, I would suspect. You can't really do that. You should have a way of buffering. A commit button would be better. But that's up to you. Okay. Deleting things. Well, I've got a... This is kind of... This gets a bit deep, actually. I've got a delete account method that returns true if it worked and false if it didn't. Which is... I pondered about this. If a method that does things... Well, here's the profound question. I'll show you the code, and then we'll get to the profound question. If I've got a delete behavior, the code is quite sensible. It says, I'll see if I can find the account. If I find the account, del is not equal to null, that's fine. I can remove it and return true. Otherwise, I return false. So if the delete didn't work, I return false, correct? Okay with that? The profound thing is, if you regard the purpose of delete as to make something not there anymore, does the fact it wasn't there in the first place mean it succeeded before it even tried? So should it return true, I couldn't find it, yes, it's definitely not there, or should it return false, I tried to kill it and it wasn't there to kill? Now, I leave that for you to ponder, because it kind of puzzled me. It's one of these. One of the other profound questions in the universe is, how do you throw away an old dustbin? Because you put it outside and nothing happens. So you have to find a bigger dustbin to put it in, so that when you throw it out, the dustbin. Anyway, so everyone's dustbin should just keep getting bigger and bigger as time goes by, and they try and find ways of. That's not what happens, but I digress. The bigger point actually is, that's the find account. Sorry, that's the behaviour to say, have we got him to delete? This is deletion, and if it worked, I return that. If it didn't, I return it didn't work. The bigger point is I'll get to it in a minute. Here we go. You really shouldn't delete accounts. I've told you how to do something for completeness' sake, but you really shouldn't delete accounts, because the bank won't like that. If we can make an account completely vanish, that's kind of like open season for all kinds of dodgy goings on, where you could create an account, move money around and then close it. The bank will not let you do that. So all this lovely stuff to do with me showing you how it's removed and how things are pulled out by the garbage man and that kind of stuff, that's not really what you do with accounts. You don't delete them. You have a thing in the account that says, I am deleted, or I'm no longer in use, or I'm closed, but you don't delete him, because that's a very dodgy thing to do. So, in terms of the wrap-up for now anyway, the bank class holds this collection of objects, which are the bank instances. They're just references, and I love the use of dictionary as a way forward on this. And once you've got your bank working, you provide the methods in the bank to actually do the things that your user interface has to do with banks. Does that kind of make sense? Everybody okay with that? I'll go through this again a little bit tomorrow to try and hammer it home. But until then, that's it for me. It's about 6:05, so I think we can call a halt.